Hello friends, I am Professor Rajendra Koranne from my YouTube channel Teach Easy. In this video, I am going to present 30 multiple choice questions on the topic of equilibrium of the subject of applied mechanics for the students of second semester diploma of automobile engineering, civil engineering and mechanical engineering. So without wasting the time, let us start. Question number 1. If the body is in equilibrium under the action of number of forces, then A. does not translate, B. does not rotate, C. neither translate nor rotates, and D. only rotates. Now when the body is in equilibrium, definitely it will not move at all in x direction, y direction, that is translation. It will not rotate at all. Hence the correct answer is C. It neither translates nor rotates. Question number 2. To avoid the translation of the body, A. sigma Fy must be 0. B. both sigma Fx and sigma Fy must be 0. C. sigma m must be 0. D. sigma Fx must be 0. Now whenever there is any translation of the body, for that translation, if it moves in horizontal direction, Fx is responsible for that. If it moves in vertical direction, Fy is responsible for that. So to avoid translation in x or y direction, both sigma Fx and sigma Fy must be 0. Hence the correct answer of this question is B. Both sigma Fx and sigma Fy must be 0. Question number 3. To avoid the rotation of the body, A. sigma m must be 0. B. sigma Fy must be 0. C. both sigma Fx, sigma Fy must be 0, and D. sigma Fx must be 0. Now for rotation, moment is responsible for rotation. Hence if there is not to be any rotation, then sigma m must be 0. Hence the correct answer of this question is A. sigma m must be 0. Question number 4. For a body in equilibrium under the action of general force system, the analytical conditions of equilibrium are A. sigma Fx must be 0. B. sigma Fy must be 0. C. sigma m must be 0, and D. all the above. Now if the body is in equilibrium, it neither translates nor it rotates. Hence we know that sigma Fx, sigma Fy and sigma all should be 0. Hence the correct answer of this question is D. all the above. Question number 5. For a body to be in equilibrium, minimum forces must act on it. A1, B2, C3 and D none of the above. Now for the body to be in equilibrium, minimum 2 forces must act on it. Hence the correct answer is B2. Question number 6. If the body is in equilibrium under the action of 3 coplanar forces, then those forces must be A. concurrent, B. parallel, C. non-concurrent, D. either concurrent or parallel. Now if the body is in equilibrium under the action of 3 coplanar forces, they should be either concurrent or they should be parallel. Hence the correct answer of this is D. either concurrent or parallel. Question number 7. For concurrent forces keeping the body in equilibrium, the necessary and sufficient analytical conditions are sigma Fx must be 0, B. sigma Fy must be 0, C. sigma m must be 0, and D. both sigma Fx and sigma Fy must be 0. Now the body is in equilibrium under the action of concurrent system of forces. We know that for concurrent system of forces, resultant also pass through the point through which all the forces are passing. So sigma m is already 0. So it is not necessary to take. So hence necessary and sufficient conditions are sigma Fx must be 0 and sigma Fy must be 0. Hence the correct answer of this question is both sigma Fx and sigma Fy must be 0, that is D. Question number 8. The Lami's theorem is applicable for a body in equilibrium under the action of A. 3 coplanar forces. B. 3 coplanar concurrent forces. C. 3 coplanar concurrent forces acting at and away from the body, from the point in the body, and D. Any of the above. Now, exact condition for applicability of Lami's theorem is to be used in this particular question. Now, when 3 coplanar forces acting at and away from the point in a body keep the body in equilibrium, then Lami's theorem is applicable. Hence, the correct answer of this question is C. 3 coplanar forces acting at and away from the point in a body. Question number 9. A free body diagram is A. An isolated body in equilibrium with all active forces acting on it. B. An isolated body in equilibrium with all active and reactive forces acting on it. C. An isolated body in equilibrium with all reactive forces acting on it. And D. An isolated body in equilibrium. Now, whenever we talk about free body diagram, that particular body is to be separated from all the contacts, and whatever active and reactive forces are acting on it are to be shown in diagram. Hence, the correct answer of this question is B. An isolated body in equilibrium with all active and reactive forces acting on it. Question number 10. If a body is in equilibrium under the action of two forces, then those two forces must be A. Equal in magnitude, B. Opposite in direction, C. collinear in action, and D. all the above. Now, when the body is in equilibrium under the action of two forces, they must be equal in magnitude, opposite in direction, and collinear in action. Hence, the correct answer of this question is D. all the above. Question number 11. The resultant and equilibrant are A. Equal in magnitude, opposite in direction, collinear in action, and D is all the above. So, definitely two forces when we were talking about, one is resultant, one is equilibrant. Hence, the correct answer of this question is D, all the above. Question number 12. 3 equal forces acting at and away from a point in a body. The body is in equilibrium, then the angle between the forces will be A. 150, 150 and 60 degrees. B. 120 degrees each. C. 120, 150 and 90 degrees. D. 135, 135 and 90 degrees. Now, the body is in equilibrium under the action of 3 concurrent forces. Now, all the forces are of equal magnitude. If the forces are equal, all the angles must be equal. So, 3 forces are there, so 3 angles are there. Total angle is 360 divided by 3. So, each angle will be 120 degrees. Hence, the correct answer of this is B, 120 degrees each. Question number 13. The beam which rests on knife edges or points at the ends is known as A. Cantilever, B. Overhanging beam, C. Simply supported beam, and D. None of the above. Now, when the beam is resting at point of contact at the ends, that is the knife edges, it is known as simply supported beam. Hence, the correct answer is C, simply supported beam. Question number 14. The beam which extends beyond support at the ends is known as A. Cantilever, B. Overhanging beam, C. Simply supported beam, and D. None of the above. If the beam extends beyond the support, it is known as overhanging beam. Hence, the correct answer is B, overhanging beam. Question number 15. The beam fixed at both ends is known as A. Cantilever, B. Simply supported beam, C. Fixed beam, and D. Overhanging beam. As both the ends are fixed, it is known as fixed beam. Hence, the correct answer is C. Fixed beam. Question number 16. The beam fixed at one end and free at the other is known as A. Cantilever, B. Simply supported beam, C. Fixed beam, and D. Overhanging beam. Now, if one end is fixed and other is free, it is known as cantilever. Hence, the correct answer of this question is A. Cantilever. Question number 17. The load which is assumed to act or concentrated at a point is known as point or concentrated load. B. Uniformly varying load. C. Uniformly distributed load. D. Concentrated moment. Now when the load is assumed to act or to be concentrated at a point, it is known as point or concentrated load. Hence the correct answer is A. Point or concentrated load. Question number 18. The load which is spread over the length of the beam such that each 1 meter length is loaded equally is known as A. Point load or concentrated load. B. Uniformly varying load. C. Uniformly distributed load. And D. Concentrated couple. Now when the load is spread over a length such that every 1 meter length is loaded equally, then it is known as uniformly distributed load. Hence the correct answer is C. Uniformly distributed load. Question number 19. The reaction at the roller end is A. Horizontal, B. Perpendicular to the surface on which it rolls, C. Vertical, and D. Inclined. Now whenever there is a roller, the reaction at the roller is always perpendicular to the surface on which it rolls. Hence the correct answer is B. Perpendicular to the surface on which it rolls. Question number 20. A simply supported beam of span L carries a vertical downward point load W at the center. Each support reaction will be A. W by 4, B. WL by 2, C. W by 2, and D. None of the above. Now here simply supported beam is carrying a central point load W. As the load is symmetrical, each reaction will be equal, that is W by 2. Hence the correct answer is C. W by 2. Question number 21. A simply supported beam of span L carries a vertical downward UDL of intensity W per meter on its entire span. Each support reaction will be A. WL by 2, B. WL by 4, C. W by 2, and D. WL. Now here UDL is acting on entire span, so total load is W into L. As it is symmetrical loading, the support reactions will also be equal, so that is half of the load, and hence the correct answer of this is A. WL by 2. Question number 22. A simply supported beam AB of span L carries a vertical downward point load W at a distance A from left hand A and B from right hand B such that A plus B is equal to L. The reaction at the support A will be A. W into A by 4, B. W into B by 2, C. W into A by L, and D. W into B by L. Now here you apply the conditions of equilibrium. There is no horizontal force, so sigma fx is already 0. If you apply sigma fy is equal to 0, you will find that Ra plus Rb is equal to W. And if you take moment of the load at either A or B, you will get the value of Rb or Ra, and finally you will get the value of support at A as W into B by L, that is dW into B by L. Question number 23. A simply supported beam AB of span L carries a vertical downward point load W at a distance A from A and B from B such that A plus B is equal to L. The reaction at the support B will be A WA by L, B WB by 2, C WA by 2, D WB by L. This is exactly the last problem in last question. Here the reaction at the right support is asked. The right reaction is proportional to the left distance, that is A. Hence the correct answer is AWA by L. Question number 24. The beam AB is hinged at A and supported on roller at B. If all the loads are vertical, then hinge reaction will be dash 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 and the reaction at the roller will be dash dash dash. A. Vertical, inclined, B. Vertical, vertical, C. Inclined, vertical, and D. Inclined, inclined. Okay. Now here Left end is hinge, right end is roller. But all the loads are vertical. So whether it is hinge or whether there is a roller, as all the loads are vertical, reaction at the hinge and reaction at the roller both will be vertical. Hence the correct answer is B, vertical, vertical. Question number 25. The beam AB is hinged at A and supported on rollers at B. If one of the loads acting on the beam is inclined, then the hinge reaction will be dash dash dash. A vertical, B horizontal, C inclined, and D none of the above. Now here A is hinge, B is roller. One of the load is inclined, definitely reaction at the hinge will be inclined, because the horizontal component of the inclined load will be balanced by horizontal component of hinge reaction. Hence the correct answer is C, inclined. Question number 26. The beam AB is hinged at A and supported on rollers at B, which rolls on an inclined surface. If all the loads are vertical, then the hinge reaction will be dash 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 and the reaction at the roller will be dash dash dash. A vertical inclined, B vertical vertical, C inclined vertical, and D inclined inclined. Now here is hinge, B is roller, which is moving on inclined plane. Okay. All the loads are vertical, but as the roller is moving on inclined plane, roller reaction at the roller is inclined, and to balance the horizontal component of that roller reaction, there must be a horizontal component of hinge reaction also. So hinge reaction will also be inclined. Hence the correct answer of this question is D, inclined, inclined. Question number 27. The graphical condition of equilibrium for system of concurrent forces is A. The funicular polygon is closed. B. The vector diagram is closed. C. Both vector diagram and funicular polygon is closed. And D. None of the above. Now the graphical conditions of equilibrium for concurrent forces. For concurrent forces, we know that only R should be 0, that is sigma fx and sigma fy should be 0 analytically. Now that R is represented in graphical method by the closing side of vector diagram. Now as R is 0, closing side, no closing side, the vector diagram itself will be 0, and the correct answer is B, the vector diagram is closed. Question number 28. The graphical conditions of equilibrium for system of non-concurrent forces is A. The funicular polygon is closed. B. The vector diagram is closed. C. Both vector diagram and funicular polygon are closed, and D. None of the above. Now as it is non-concurrent system, both resultant and moment must be 0. Therefore, graphically, both vector diagram and funicular polygon must be closed. Hence the correct answer is C. Both vector diagram and funicular polygon are closed. Question number 29. The equilibrant of the system of concurrent forces is represented graphically by A. The closing side of force polygon in same order. B. The closing side of the force polygon in the reverse order. C. The closing side of force polygon. D. None of the above. Now we know that graphically the resultant is represented by the closing side of the force polygon in reverse order. Now we are asked about equilibrant in this question. We know that equilibrant is equal, opposite, and collinear. So if resultant is represented in opposite order, the equilibrant must be represented by the closing side of the force polygon in the same order. Hence the correct answer of this question is A, the closing side of the force polygon in same order. Question number 30. If the body is in equilibrium under the action of 5 concurrent forces, the vector diagram will be A. Closed polygon, B. Open polygon, C. Closed hexagon, and D. Closed pentagon. Now here the body is in equilibrium, so vector diagram will be closed figure. So A closed polygon is partially correct. B open polygon is wrong. C closed hexagon is also wrong because there are 5 concurrent forces, hexagon has 6 sides. So the correct answer is D, closed pentagon. Thank you.